All right. Well, welcome. In this video, we're going to start a brand new chapter. This new chapter is going to be all about quadratics. And so we're going to come back to this box at the top of your notes and fill this in at the end once we've talked about some of these different characteristics and different terminology that you want to be familiar with. So we'll come back to that. And actually, you should already know how to do questions, at least questions 1, 2, 3, and 4 with describing the different transformations, because that's a review of what we did last chapter. So we're actually going to start there. I want you to do this as a warm-up. So I want you to pause the video, and I want you to see if you can't figure out what transformations are taking place for each of these functions. And then with the last two, with 3 and 4, if you can, see if you can't graph what those would be based on what you know and what you did with us last chapter. If you can't graph it, don't worry about it. We'll look at that in a minute once you hit play. So why don't you guys go ahead and pause the video, work on these 4, and then hit play when you're ready to check your answers. All right. Let's start with this first one. So this first one, you can see that since we have a negative there, and we have the 1/2, and then in the parentheses there, we have x plus 2 quantity squared. So inside of parentheses, that means it's going to move to the left 2, and then the negative means it's a vertical flip, and the 1/2 means it's a compression by 1/2. By the way, the negative is not what makes it a compression. When we look at that value outside the parentheses, you always take the absolute value of it. So ignore the negative. And so the 1/2, since that's between 0 and 1, it's a compression. If it's bigger than 1, it would be a stretch. So it's a compression by 1/2. With this next one, again, inside of parentheses, we have the x minus 1. So that means it's going to go to the right 1. And the minus 3 means it moves down 3. The 2 that's outside of there, this time that's bigger than 1. So that'd be a vertical stretch by 2. And it's important to be specific with that, because we could have horizontal stretches and compressions. So it's important to say what direction it's going. So it's vertical. And the fact that this is a stretch, not a compression, and then by how much. All right, we'll talk about the graphs here in a second. So let's look at what would be happening in this one. So this one we had a negative quantity x plus 2 squared. So the negative means that you'd have a vertical flip, and inside the parentheses we have plus 2, so that means we move to the left 2 units. Now how does that look graphically? Well, what's in red here is our parent function. And I want you to notice something about this pattern. There's a very important pattern here. With that parent function, y equals x squared, the x is your horizontal. So if we go to the left 1 unit, if I put 1 in there for x, 1 squared is 1. So the result is I go up 1 unit. Or if I wanted to go to the right 2 units. So if I put 2 in there for x, well, 2 squared is 4. So we would go up 4 units. And so on. So we repeat that pattern. If we put 3 in there, we'd have 1 over 3. We would go up 3 squared to be 9. Now that's important when we go to flip or stretch or compress the graph. Because when I move this one, so this one again is going to move to the left 2 units, but it's going to be flipped vertically. Now some would say flip it vertically first, or you could always just flip it over the vertex. So I move this one to the left 2 units, and then to flip it vertically, we're going to go to the right one, and because we're not stretching or anything, it's just that it's being flipped. So instead of going to the right one, up 1, I'd go to the right one, down 1. And instead of going to the right 2, up 2, I'd go to the right, or I'm sorry, right 2, up 4, I'd go to the right 2 and down 4. So that's how you can get some points. And then we could reflect those points. We'll talk more about that here in a little bit. And then that gives you the parabola. All right, well, what if it's stretched or compressed? So this one, we can see that it's moving to the right 1, up 2, and then we have a vertical compression by 1/2. But let's look to see how that looks in the graph. So remember, I like to start with the translations first. So go to the right 1, up 2. And now let's do the compression. So instead of going to the right 1, up 1, like we normally would, it's being shrunk or compressed to be half the size. So instead of going up 1 unit, we would go up a half a unit. Or if we go to the right 2, 2 squared, remember, would go all the way up to 4, but we're going to compress it to be half the size. So instead of going up 4, we would go up 2. Then again, reflect those points and you get your parabola. All right, so I've used some vocabulary that we should be familiar with. So let's look at the next page. And let's talk about Let's do number 5 together. We're going to talk about the different transformations, and then we're going to talk about some of this vocabulary. All right, let's talk about the transformations first. So this first one, so we see that it's going to move to the right 3, down 4. Okay. And then the 2 means that it's going to be a vertical, I'm just going to abbreviate this, vertical stretch by 2. All right, so I like to do the transformation or translations first. We're going to go to the right 3, down 4. Okay, that's what we call our vertex. Now it's going to be vertically stretched by 2. So that means I'm always going to, so that doesn't affect the graph horizontally, so we're going to still go to the right one. But instead of going to the right one, up 1, I'm going to double that. So instead of going to the right one, up 1, I'm going to go to the right one, up 2 to get that other point. Let's come up with some other points. So again, normally we would go for the parent function, we go to the right 2, up 4. But if I double that, it's going to go up 8. So here's 4, 5, 6, 7, 8 would go up to here. So again, you're doubling the graph vertically because it's being stretched to be twice the size. Now, it might be kind of hard to figure out, well, where do those other points go? Now, let's talk about this idea of reflection. So it's going to be reflected horizontally. So we have this, what we call this axis or line of symmetry. That line of symmetry is going to go up vertically from that vertex, or go down vertically if it's opening downwards. And it's nice because this just gives you a visual. So this point that's right here is 1 unit to the right of that line of symmetry. So I'm going to put another point 1 unit to the left of the line of symmetry. This one up here, that's 2 units from that line of symmetry. I'm going to reflect it, so there's another point 2 units to the left of the line of symmetry. And now we can be more accurate with our graph. All right, so let's go down here and let's establish more of these vocabulary words. So the vertex, remember the vertex can be the lowest point, it can be the highest point, but it's a point where the graph changes direction. For this, it would be the point where x is 3, y is -4. So that would be the vertex. Now the axis of symmetry, that's going to be a vertical line for these. So it's always going to be the form x equals something. So in this case, the vertical line was going through where x is 3. So it would be x equals 3. And it's the entire piece. It's not just 3. So if I ask you what's the equation for the axis of symmetry, if you just said 3, that was wrong. It's got to be x equals 3. It's always an equation for a vertical line for these. So it'll be x equals 3. All right, let's look at what it means by maximum or minimum value. So when the graph is opening upwards like this, the vertex is the lowest point. And the value of that is the y value. So that's at -4. So we would say it's a minimum value at -4. Whenever we say value, it's referring to the y value or the y-axis. For that, you don't have to say an equation, so we would just say the minimum value is -4. The nice thing is for these, the domain will always be the same. The domain is always -infinity to infinity. And then the range depends on where the vertex is at. So in this case, the vertex again is the lowest point, so there's no points below -4. So the range would go from -4 up to infinity. Hopefully this is something that you're familiar with after last chapter. All right, so now here's what I want you guys to do. I want you guys to do the same thing with this one. So now you should know how to graph this one. So I want you to graph this one and then find all these key elements, the vertex, axis of symmetry, maximum, minimum value, and domain and range. So I want you to pause the video and hit play when you're ready to check your answer. You did here. So for this one, you should have had these transformations. Whether or not you wrote them down, that's fine. But we're going to flip it vertically. It's going to move to the left 4, up 5. So if I start with the vertex, moving to left 4, up 5, we get a vertex up here. And when we flip it vertically, that means there's no stretch or anything. So we're going to go to the right 1, down 1, and the right 2, down 4. And then we can reflect those over the line of symmetry. We see that it goes off the graph here. That's totally fine. So that means our vertex will be at negative 4, 5. Your equation for the axis of symmetry is x equals negative 4. It's got a maximum value at 5. The domain is always negative infinity to infinity. And since it's going downwards, it's coming from negative infinity, so there's no lowest point. So it starts at from negative infinity, but it goes up to 5. So I always start with the smallest value first, highest or largest value second. All right, before we get to these next examples, I want to go back to the previous page. There's an equation that we kind of skipped over on purpose. That's this one right here. So we're going to have some different forms for our quadratics. One of them is a vertex form. We're going to talk about another form here today called the standard form. But it's really important that you recognize that that's what this is, a vertex form. So if you have my notes, you can circle that and draw an arrow over it. Just remember that that is the vertex form. Now, what does a vertex form really mean? Well, the reason why we call it the vertex form is we can quickly identify the vertex. The vertex is going to be the coordinate h, k. So h would be the x value of the vertex, k would be the y value of the vertex. And a tells you what's happening with the graph vertically. If it's being flipped vertically or stretched or compressed vertically. So let's see what we mean by that. In this, get to it. In this next example, it says what is the equation for the quadratic function with a vertex at negative 2, 3, and a y-intercept of negative 1. So the first thing I'm going to do is I'm just going to rewrite that formula. Now it's important to remember that this is a quadratic, so you should have a square there. One of the most common mistakes is people just get excited and forget about that little square and then get frustrated when they lose points on a test. So don't forget that, because that identifies the fact that we are working with a quadratic. All right, so now let's see what we know. We know that it has a vertex at negative 2, 3. So remember, that means that that's our h and k value. So I'm just going to plug in what we know. So h is negative 2. If I wrote this down as x minus negative 2, minus a negative, remember, becomes a plus. So it should be x plus 2 quantity squared, and then plus our k value, which is 3. Well, now we need to figure out, well, what's this value for a? There's a small little process that we're going to have to use to find out what that a value is. So to find a, we're going to use the given coordinate. Well, you might be saying, well, what do you mean? What coordinate? What other coordinate do they give us? All I see is a coordinate for the vertex at negative 2 and positive 3. We already used that. Well, they also tell us that the y-intercept is negative 1. Well, what does that mean? Remember, think about the y-axis. Where it crosses the y-axis, that's always where x is 0. So that would be the coordinate 0, negative 1, where this is your x, where these 0 is x and y is negative 1. So we're going to plug that in to our equation. So I'm going to replace y with negative 1. Whoops, I almost made a mistake here. Now I'm going to replace x with 0. So it'll be 0 plus 2 in parentheses squared plus 3. And now we're just going to solve for a. Now be careful with that. So let's look at what we have here. 0 plus 2. All right, 0 plus 2 would be 2, and 2 squared would be 4. So I'm going to write this as 4a plus 3. So we would not add 4 and 3 together. Okay, it's 4a plus 3. So when I go to solve this, I would subtract 3 from both sides. Running out of space here. So I would just divide by 4, and we get a is negative 1. So that's what we're going to use in our equation. A is negative 1. So our equation is y equals negative 1 times x plus 2 quantity squared plus 3. Or we could even just said negative quantity x plus 2 squared plus 3. But that would be your final equation. So we're done with the 0, negative 1, so we don't use that anymore. We only use that to find the a value. So your equation, you leave the x and the y in there. Don't replace the x and y with any numbers for a final equation. That would be your answer. All right. I want you to pause this video now, and I want you to try this. I know that we just did this for the first time, but I want you to try this with the next one. See how far you can get, but follow the same process that we did on the previous one to figure out what your equation would be. So go ahead, pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so first thing we're going to do I'm not going to rewrite the equation like I did the first one. I'm going to just write it like this. We'd have a, and then our h and k would be 1 and -4. So it would be x minus 1, quantity squared. So plus -4, I can write down -4. So now I want to find out what a is. So for this time, find out what a is. They actually give us the coordinate, -2, -1. So whoops, instead of y, it would be -1 equals, so sorry about that, let me erase that. So it'd be -1 equals a times our x value, which is -2, is 1 quantity squared, and then -4. So we put -2 in here for x, put -1 in there for y, and now let's simplify that. So on the left side, I'm going to leave that as -1. On the right side, -2 minus 1, -3. -3 squared is +9, so I'm going to write that as 9a minus 4. Now when I add 4, because to solve for a, I have to add 4 to both sides. When I add 4 to both sides, I would get 3 equals 9a. Now make sure you divide this properly. It's not always a bigger number divided by the smaller number. It's a number that doesn't have the variable 3 divided by the number with the variable 9. We always reduce. That reduces to 1/3. So our equation would be y equals 1/3. So now we know what a is. Put in the rest, x minus 1 squared minus 4. So that would be your equation. All right, we're going to end by talking about another form. So we have vertex form, and now we have standard form. So if they give you something in standard form, sometimes we're going to rewrite it into vertex form. So this one is asking us to write the equation from number 7. So number 7, we had this equation. And there's a process we're going to follow. The first step is we're going to square it. Now squaring means we multiply it times itself. Squaring does not mean that we take and square, we distribute the square inside the parentheses. That is not what we do. We have to multiply x plus 2 times itself. I like to use this box method. And so this box method just helps give you a visual. So we're going to multiply x plus 2 times x plus 2. So watch what happens. When we multiply x times x, we get x squared. X times 2, we'll write that as 2x. 2 times x, we'll go to the bottom row now. 2 times x is 2x, and 2 times 2 is 4. So now notice how I'm going to write this. It's going to be in parentheses x squared. Now the two x's, those two are like terms, so we're going to add those together. So that would be plus 4x and then plus 4. And the reason why it's important to have this in parentheses is because that negative that's in front applies to everything it is for x plus 2 squared. So whatever that ends up being, we have to apply that negative to everything. So that brings us to our next step. Our next step is to distribute. So we distribute that negative through, so it would be negative x squared minus 4x minus 4, then bring down the plus 3. So our last step is to simplify. Do that by combining any like terms. So the negative x squared minus 4x stays the same, but negative 4 plus 3, that combines to be negative 1. So that's your equation in standard form. So we're going to do things a little differently because this next one, instead of doing it for number 8 where we have a fraction and it gets ugly, I want you guys to first have a little bit more practice with this before we do an ugly one like that. So I'm going to have you guys do this one. So 2 times x minus 3 squared minus 10. So why don't you guys go ahead and instead of doing number 8, I want you guys to follow the same process that we did with squaring, then distribute, then simplify for this equation. So pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so when you square the x minus 3, this is what you get. Again, we have our like terms, negative 3x and negative 3x. So we would have y equals 2, and then the quantity x squared minus 6x plus 9, because negative 3x and another negative 3x would be negative 6x. Next, we will distribute. So we get 2x squared. Oops, I forgot my minus 10 here. Maybe you're hollering at the screen, say, Miss Murphy, what about the minus 10? Yep, we got to include that. So distribute the 2 through. So we get minus 12x plus 18, and then the minus 10. The last step is to simplify. So to simplify this, we're going to combine like terms. 18 minus 10 is 8. So that's your equation in standard form. So now if you'd like, you can pause this video now and go back to the beginning and fill in that box. Instead of having non-examples, I wrote down the different forms that we could write our equations for our quadratic functions. Now we have not talked about factored form, so don't worry about that. We will get to that in a different section here. But everything else is all things that we've talked about today. So go ahead. That is the end of the notes, so you can pause this and then work on your assignment.